are going to solve this problem, valid parenthesis string, right? So in this problem, let's go through the problem statement first. So we have given a string s and it contains three types of characters. That will be an open bracket, a close bracket, and an asterisk. And we have to return true if the string is valid. Now the string s would be defined as valid or invalid based on certain rules that have been given the problem. So first rule is like for every left parenthesis there should be a corresponding right parenthesis, right? So like for this example, like for this open bracket there is a corresponding close bracket, right? So that's first thing. And any right parenthesis must have a corresponding left parenthesis. So that also is seen in this example. Like if we have a closing bracket, for that correspondingly we should have an open bracket. Now the third part is left must go before the corresponding right parenthesis. So left should come before right, right? For example, if we have use example like this, open and then close, right? So for this first open bracket there is a corresponding close, but there is no open bracket for this one, right? So there should be an open bracket before the closing right bracket, right? And the fourth point is, if we have an asterisk anywhere in the given string, right, it could be treated as an open bracket, or it could be a closed bracket, or as an empty string, right? So basically in case of asterisk we have three possibilities. Like it can be translated into any of three which are mentioned here, right? So that's about the problem statement. So let's go about thinking how we can actually solve this problem. And before we even go into that, right, so what we can actually derive from the problem statement. So if we look at this fourth point, right, so it shows that we have to make some choices whenever we encounter an asterisk. For other cases it's quite straightforward. Like if we encounter left, then there is if we encounter a left bracket, then there is no ambiguity, or we don't have to make any choice. Similarly in case of right bracket also. So but in case of asterisk we have to make some decision, and for making that decision we have three choices. Now what else we can extract? We can see the constraints. So in constraint, like we have been given the length of the string is relatively small, right? So if you look at this problem, you could think of going in the direction of using recursion, right? Because generally if you see the constraints, if they are this small, they could be solved via recursion, right? Because if this constraint would have been large, using the recursion could give you time limit exceeded. But let's see whether we are able to solve it via recursion, or we have to go, or we have to optimize basically that solution, right? So that's the first part. So I hope at least the problem statement is clear from just going through it. So let's try to understand how we can actually solve this problem. So let's see, like if we have let's go through the example, right? So if we have this example which is given, second example, that is open, asterisk, and close, right? So we have open bracket, and then we have an asterisk, right? And then we have a close bracket. So since we have, so basically in order to solve this, right, we have to make a choice how this asterisk can be resolved into. So as given in the problem statement, we can make three choices, right? So either this asterisk can be open bracket, or it can be close bracket, or it could be an empty space, right? So in order to solve this problem, since we have an open bracket, and if we use this example, right, so if we replace the value with open bracket, so it would become open, open, and then close. So it is not a balanced brackets, right? So there are two opens and one close. So that's not a valid solution. If we go or use this like in place of an asterisk, so basically it will become open, close, and close, right? Open, close, and close. So basically in this case we have one open and two close. So that is still not a valid answer. But if we replace it with an empty string, right, so what it will become, it will open, then we have empty, and then we have closed bracket, right? So in this case we have one open and one close, right? And this is a valid answer, right? So let's see another example, right? What's the other example that we have been given in the problem? It's like this one, which is an open, asterisk, close, and close, right? So if we look at that problem, so we have an open bracket, then we have an asterisk, right? And then we have close, and then we have again close. So okay, let's go step by step. So if we have an open bracket, then it's clear, like we don't have to make any choices, right? So that's an open. So we will at level 1 or at the 0th level, what we will have is an open bracket, right? So that's fine. Coming to the first level, right? So basically what I mean by level is like if you assign corresponding index to each of these values, right? So then what we will have, so right now if we are at the 0th level or at the 0th index here, then it is an open bracket. So in this case, like we don't have to make any choices, and we know, like I will also keep on mentioning the open and closed bracket counts, right? So here we have like an open bracket. So in this case it's fine, like we don't have to make any choices. Then we come at level 1 or index 1. So at this index we can have three choices. Basically we have to decide like what we have to put in place of this asterisk, right? So it will become basically an open bracket that is coming from the previous index. Here in the place of asterisk, now we can place like basically a close bracket, right? Or what we can do is like so these are the three possibilities that we have: open. So these were the initial three, like that are coming from the previous index. Now coming in place of asterisk, since we can have three possibilities, so it would be like a close bracket, or it could be an open bracket, or it can be an empty string, right? So these are the three possibilities. Now so these are the three possibilities basically that we have to explore, right? So these are the three possibilities. Now coming to the going forward to the next index, that is second index now. So here now what we'll have is like we have, and now taking from carry forward from the first index. Now for this use case, right, for this use case we are talking about, so we have an open bracket, then we have a close bracket, and then we are at level 2 or index 2. Now we will have again a close bracket, right? So this basically violates the constraint that is given in the problem. Like we don't have any corresponding left bracket at this point. So how we are actually tracking this one is like at any point, if the count of closed brackets, right, here in this case it is 2 and open bracket is 1. If the closed bracket count becomes greater than the open bracket, then it is an invalid solution, and we will return false to the calling method basically. Okay, so this is not going to give a possible solution. So let's move on to the next use case. So here we have an open bracket, then again we have an open bracket. We are talking about this use case. Okay, so we have open bracket, and since we are at level 2 and here we are considering a closed bracket, so we have this closed bracket, right? So this one is fine. Now moving to the third use case, that is this one. So here we have an open bracket, then an empty space, and now at the index 2 we have a closed bracket. So this is also fine. Up till now these two cases are not violating any of the condition, that is open bracket is less than or equal to the closed brackets. So I hope that is fine, and that is clear up till now. So let's go to the third level, right? So what we have at the third level or third index is again a closed bracket. So we are at third index and where we have a closed bracket. So this case is already eliminated, so we are not going to traverse that. So coming to the this case, we have an open bracket, closed bracket, that's carrying forward from here, and now at the level or at index 3 we have a closed bracket, right? So here we see like all the open bracket and closed bracket are equal, and it is not violating the condition that closed brackets are more than open brackets. So this is fine. And not only that, we have reached the end of the string, right? So since we have reached the end of the string here, so basically what it will do, it will return true to the calling function. Okay, now going to this use case, like here we have an open bracket, closed bracket, and closed bracket. Now what happens is like here again we see like the counts of closed bracket have become greater than the open bracket. So basically this is violating the constraint that is given in the problem, right? So this one will return false. So if you see now again if we go step by step up, so this one will basically return false to this calling function, and this is the use case or one of the possibilities which is returning true to the calling function, right? And again when so at 0th index we had three possibilities, or it has called three functions or child functions, right? So out of these three, one have returned true, so in its calling function it will return as true, right? So that's how it will the recursion tree would look like, and that's how we are going to solve this problem, right? I hope at least this part is clear. So let's go to the editor to see how we can actually solve this problem, right? So in this problem, like as we discussed, like we are going to maintain three variables, basically int open, that is 0, and int close, which is also going to be 0, and then we are going to have at index where we are, right? So we are right now at the 0th index, and then we are going to simply call a function which will be taking three parameters like we have created above. That is where right now we are at the index in the string. Then we will pass the number of open bracket counts and number of close bracket counts. Okay. Now we are going to write a function which will of type boolean, because that's we want to return in the problem, and write receive three parameters. Okay, so we have int at, int o, and int c. Okay. Now as we discussed, what would be the terminal conditions, right? So first terminal condition is if at any point the close brackets become greater than open bracket, right? At that time we have to return false. Okay, and if at any point, let's say we reach the end of the string, right? And we reach the end of the string, right? As we are seeing here, at any point if we reach the end of the string and the open and close are equal, right? In that case we have to return true. Okay, so here if you see at any point, if at is equals to s dot length, right, and we have open is equals to close, then we have to return true, right? And there is another use case like this one where we have reached the end of the string and the brackets are not balanced, right? That is closed becomes greater than open, then at that time we have to return false. So if at is equals to s dot length and close becomes greater than open, at that time we have to return false. Okay, so these are three possibilities. Now at any time, since there are multiple possibilities, so let's create because so basically what happens here is, like if you see here, at each index we have to make three choices, and there will be multiple call to the same function, right? Recursive we will call to multiple functions, and whatever the outcome we got from those three function calls, we have to check either one of them is true, then we have to return as true, right? So in this case we are going to maintain a boolean variable like answer. In this case it is going to be false, but the moment any of the child functions that we are going to call, if it returns the value as true, right, so we will make this answer as true. Okay, so let's go case by case. So first case is if we return an open, if we receive an open bracket, right? So if we are at, so let's try to also store that here, right? So let's make a char variable ch, and it is going to be okay, so we are also going to receive s as an input, right? That part I missed. So we are going to receive string as an input, and for that let's try to get that character here. So s dot char at, right, at. So now we have the character stored here, and the first case is if we receive this character as this open bracket, right? So if ch is equals to as an open bracket, right? If that's the case, then basically what we have to do is we have to, so basically why I'm using or is like if in case like the function that I'm calling that returns true, so it will make answer as true, right? Because right now answer is false, and let's say the recursive function return the value as true, so it will make the answer as true, right? So that's why I'm using or operator here. So we are going to pass s, and then we are going to add +1 because current character or current index is we have solved it, right? So we are going to move forward to the next index, right? And now since it is an open bracket, so o +1 it will become, and close will remain as it is, right? So this is the case one. So okay, the next case that we are going to, when we are receiving a closed bracket, right? So if we receive a closed bracket, that is ch is equals to close, then in that case basically what will happen is like we have to pass s comma at +1, open will remain as it is, and close will become 1 plus. Okay, now the third character is third case basically is when we receive an asterisk, right? So in this case we have to make we have three choices basically. If ch is equals to asterisk, right, then we have three possibilities. So our answer would be like a function of s comma at +1. So this part we already explained because we are going to the next index, but here in this case we are considering if it is an open bracket, right? So if we considering it like if it becomes as an open bracket, then we are going to have open +1, right, and then as close. Or second, like if we consider it becomes as a closed bracket, then answer would become, right, a function of s comma at +1 comma open will remain as it is, but close will be increased by 1. Or we consider it as an empty space, right? So answer would become function of s comma at +1, and open and close will remain as it is, because we are not incrementing the count of open and close because it is an empty string, right? So this is like the basic all the use case that we have, and in the end we'll just simply return the answer. Okay, So if we just okay, so I think this should solve the problem. Let's just try to test it and see if it works or not, right? Okay, so we are getting array index out of bound here, and to understand why we are getting this index out of bound exception, it could be because like we are going to the end of the length of the string, and that means like one of our base condition is we are missing something. So so here we have put if close becomes greater than 0, right? I think this condition is actually required to be fixed. Uh, so basically, if we have this use case, so if we are reaching the end of the statement and if close become greater than open, then this is an invalid case. But there is one more actually case, this one, right? Where it could lead to like the close can also become greater than open and we have reached the end of the string, right? So if we are reaching the end of the string and basically the open and close are not same, then in that case we should return false, right? So that should be our another base condition. So let's try to fix that. So here close, if it is not equal to open, then in that case it should return false, right? So let's try to run now and see if we are getting the required answer. Right. So now the solution is working fine. So, but let's try to submit it and see if the solution is getting accepted. So basically, this will give the time limit exceeded because like as you can see only 79 test case pass and we have to pass 83, right? So let's try to optimize the solution further. In order to do that, like let's try to basically memoize it, right? So what we have done is like we have written a recursive solution, and but for that also we are getting the time limit exceeded. In order to memoize it, right? So let's see how many variables we have in this function. So here you can see we have 3 variables that are changing, right? We have at, open bracket count, and close bracket count, right? So these 3 variables are there that are changing. So how we can in order to maintain a state at any instance of time for this function, so we need to maintain the state of these 3 variables, right? So in order to do that, we are supposed to have a 3-dimensional array to store the state, right? So basically what we will have is like we'll create a boolean 3-dimensional array and call it dp, right? And in order to store the length also, we need to create one more variable that would be intn, right? That would be the length of the string, right? And to initial, now we need to initialize the dp array, so it would be dp boolean, right, of n plus 1, n plus 1, right, and n plus 1, right? So these are the, this would be our dp array which will be used for memoization. So basically, since it is why we are using boolean object and not a boolean primitive data type, right? That's because like we have to distinguish between true, false, and right, we need to have a third state that would be a null. Basically, if we want to distinguish like whether we have already evaluated that solution or not, in that case the solution can be true, false, and the third value which will let us know whether we have already evaluated that solution or not. So in that case null would let us identify that. So how we will do it, it would be like we have before coming to here, like evaluating the solution, we will check if like the dp array at open and close, if it is not equal to null, basically that means like we have evaluated it before. So we will simply return this value, right? Because we have already evaluated it, right? And if we have not evaluated it, then we will do all the processing, right? And in the end we will just store it again, so that in the next iteration if somewhere we encounter this, so whether we are able to solve that or not. So basically we'll be able to use it again, right? So to avoid the recomputation. So once we are done with that, let's try to use this test case and see whether it is passing or not. So okay, we are getting s dot size, so this should be s dot length, right? And if we try to run it, let's see whether the TLE is resolved or not. So this test case is now passing. Earlier where we were getting the time limit exceeded. So let's try to submit it now and see it should go through, right? So yeah, this is passing now. So just for a quick recap, so basically what we did is like we have first of all written all the possible scenarios that are possible in case of asterisk. So this was the core problem. where we have to make the decision to either choose an open bracket or closed bracket, or just to choose an empty space. And for that we will have three possibilities, and all these three possibilities can change our answer, right? So we try to write this recursive solution, but we were getting time limit exceeded. So to do that, we created we optimized it with the help of memoization. So we created a dynamic programming array, and then we added this condition. So to just check we have already computed the solution, and if we have computed that, then we simply return it, and if we have not computed it, then we have stored it for the further uses. So that's how like this problem can be solved. So do like, share and subscribe this video, and yeah, see you soon.